Hi, good morning everyone. Today I am taking about the OS operating system in CPU scheduling algorithm. Myself is D.CHITHRA, IT department assistant professor in S.A. Engineering College. Okay, now we go to the topic in CPU scheduling in operating system. So first, before that, we see that what is meant by CPU scheduling. CPU scheduling is the process of deciding which process will own the CPU to use while another process is suspended. Okay, so in this CPU scheduling, it's having more number of types is there. So before that, in these types of the CPU scheduling, it's a main thing is the terminology of the CPU scheduling. The first one is the arrival time, next one is the completion time, burst time and turnaround time. So each and every CPU scheduling algorithm is given that the arrival time and burst time. So first one, what is meant by arrival time? So arrival time means is nothing but the time at which the process arrive in the ready queue. Okay, so next one is the completion time, the time at which the process completes its execution. So each and every process we start from the zero itself. Next one, burst time already is given in this problem, time required by the process for CPU execution. The final one is the turnaround time. We find out that the turnaround time, it's nothing but the time difference between completion time and arrival time. So this is the terminology of the CPU scheduling. So it's a main two types of scheduling is there. One is that the preemptive scheduling and non-preemptive scheduling. So what is meant by preemptive scheduling means preemptive scheduling is used when the process switches from running state to ready state. So this process is called preemptive scheduling. Non-preemptive scheduling means it's nothing but when the process terminates or when the process switches from running state to waiting state, it's called the non-preemptive scheduling. So it depends upon the scheduling algorithm, we assign that which one is the preemptive and non-preemptive scheduling. So how to calculate the turnaround time? So in this arrival time and burst time is given in your problem. So how to find out the turnaround time means it's nothing but we find out the completion time. So in this completion time minus arrival time, it's a turnaround time. So what is the waiting time means? Waiting time is nothing but the turnaround time minus burst time. Okay, already I told the arrival time and burst time is given in your problem. Okay, so now we see that the types of scheduling algorithm. So the first one is that the first come first served scheduling algorithm, that is it's called FCFS. Next one is the shortest job first scheduling algorithm. Next one is the shortest remaining time first scheduling. Next, priority and round robin. So in this section we see first three types of scheduling only. Okay, so next section we continue on the preemptive and round robin scheduling. So first one is the first come and first served algorithm. So FCFS is a preemptive or non-preemptive means FCFS is the non-preemptive scheduling. So in this one, why it is called FCFS is a non-preemptive scheduling. So this is the first one. FCFS is a CPU scheduling algorithm which execute the process that come first. Okay, so it is called non-preemptive scheduling. So the process ID is given. So the process number of processes P1 to P5 here it's given with the 5 process. Arrival time is given. The burst time is given. Okay, so in this first come first serve, that is the FCFS scheduling algorithm, first come first serve. So in this arrival time start from the 0. So which process is come first? So P3 and P4 both are same arrival time. So first process is P3. Okay, it's in this P4 before the P3 is arrived. So first process is P3. Next is the P4. Next what is the arrival time? P1 is the least arrival time. So P1, next P2 and P5. Okay. So now we first find out the solution in draw the Gantt chart. So in this Gantt chart, first you already I told each and every scheduling algorithm the Gantt chart start from the 0 itself. Okay. So in this P3 we start from 0. So what is the P3? Arrival time is 0. What is the burst time? 4. Okay. So P3 is 0 to 4. Next, in this fourth one, we start from the next process. So what's the next process? Next process arrival time 0 is P4. So what is the burst time is 7. So 4 plus 7 is the 11. So P4 is completion time is 11. So this is the completion time. Next process is P1 because P1 arrival time is 2. Okay. So the P1 arrival time 2. So what is is the burst time? 2. So 11 plus 2, 13. Next, the smallest process is P2. So what is the arrival time? It's a 5. So the least arrival time. So what's the burst time is 6. So 13 plus 6 is 19. So the last process P5, the burst time 4. So 19 plus 4, 20. So 3. So this is the Gantt chart. So each and every scheduling Gantt chart starts from 0 itself. So this is the first come first serve scheduling algorithm. So the first come first serve means arrival time, which process is arrived first. So the arrived first is two processes means you start from the first process P3 and P4 it's arrived first. So we start from P3 itself. Okay. So now we know that the arrival time and burst time, this both or it's given in this problem only. Arrival time and burst time it's given in your problem. So now to calculate the completion time. Completion time we find out from Gantt chart only. So first process is P1. So P1. So this is the P1. So what is the completion time? The last time 13. So this is the completion time of P1. So next one P2 completion time is 19. P3 completion time 4 and P4 completion time 11. P5 completion time is 23. So now we find out the turnaround time. Already I told the turnaround time equal to completion time minus arrival time. That is the CT minus AT. So 13 minus 2, 19 minus 5, 4 minus 0, 11 minus 0, 23 minus 7. So this is the turnaround time. Next one is the waiting time. So waiting time means it's nothing but turnaround time minus burst time. So turnaround time already we know that the burst time is given. So just we minus the waiting time is calculated. Okay. Finally you find out the average waiting time and average turnaround time. So the average waiting time means it's nothing but just you added that 9, 8, 0, 4, 12 divided by number of processes 5. So divided by 5. Similarly turnaround time, average turnaround time 11 plus 14 plus 4 plus 11 plus 16 divided by number of processes 5. So this is what. Okay. So now you find out the average waiting time and average turnaround time. This is the first method. So the same method in this FCFS a second problem is given. Here P1, P2, P3. This is the 5 processes given, arrival time and burst time. So we know that the first come first serve, we start from the least arrival time. So we start from the 0. Okay. So the first process is P2. This is the Gantt chart. 0 from start from 0. The first process is P2. So what is the burst time? 1. So what is the next least process? P1 and P3 both are least process only, but we start from the P1. Okay. So what is the burst time? 2. So what is the arrival time in P1? P1 arrival time is 2, but in this P2 burst time, that is the completion time is 1. Okay. But P2 is arrival, sorry, in this P1 it's arrived at 2 only. So in this 1 to 2 CPU will be ideal. So this is the second method. Okay. So in this P1, P2 completion time is 1. So P1 will be arrived at 2 only. So in this between 1 to 2 CPU will be ideal. So after that the 2 P1 will be started. So the what is the burst time? 2. So 2 plus 2 4. Next one P3 will be started. The burst time is P3 burst time is 3. So 3 plus 4 is 7. Next P4 and P5 and so. So remaining all are same only. So you find out the arrival time, burst time is given. You find out that the completion time, turnaround time and waiting time. So finally you find out the average waiting time and average turnaround time. Okay. So in this problem the ideal is very important. The arrival time is greater than the completion time of the process, means that in between the CPU will be ideal only. Okay. Next we go to the shortest job first algorithm. So in this shortest job first algorithm, already I told it's having two types. One is the shortest job first, another one is the shortest remaining time algorithm. So both are same only, but in this preemptive and non-preemptive only different. Okay, that's the SJF is the shortest job first, is the it's a non-preemptive algorithm. SRTF is the preemptive algorithm. Suppose here the process and burst time is given. Find out the preemptive shortest job first, means you find out the SRTF. It's a non-preemptive means you find out the SJF. Okay, both are the problem is given that the same only. So here it's a 4 process is given, burst time is given. So arrival time it's not given means you find out just you take down the arrival time, it's 0 only default. Okay. So the Gantt chart, first you draw the Gantt chart. Already I told that each and every Gantt chart start from the 0 itself. So first what is in the first one? Short shortest job first. So in this one, which process, that is the job is shortest one. Here the shortest job is 4. Okay, so first we start from the P3 process. In this previous one, first come first serve, which arrival time is lesser. Okay, so which one is the arrival time is lesser, that process will be started first. Here shortest job first is the which job is shortest one, we start from that process first. Okay, so here the process, first process shortest job is 4, so we start the process is P3. Next both are 6 is the, okay, 6 means we start from the first process, so P1, next is the P4, last one is the P2. Okay, so same the 0, next burst time is 4, so 0 to 4, next process is P1, so 4 plus 6 is 10, next process is P4, see 10 plus 6 is 16, next process is P2, 10, so 16 plus 10 is 26. Okay, this is the Gantt chart. So now you find out the, similarly you find out the completion time, turnaround time and average waiting time. It's similar to the previous one, that is the FCFS. Finally you find out that the average turnaround time and average waiting time. Okay, so this is the two types of scheduling algorithm, that is the shortest job first and FCFS. So in now you will see that the some gate questions. In this gate question we solve that the SRTF also. First problem, consider the following table, find out the average waiting time using FCFS, that is the first come first serve. Okay, here arrival time and burst time is given, so you know the first step you draw the Gantt chart. Okay, so Gantt chart, so which arrival time is lesser, that is the FCFS. So we started the process is P4, so this is just you assign that P1, P2, P3, P4 and so on. So we started the first process P4, next 1, okay, both are same, so we started the P2, next P5 and next one is that 2, both are same, so P1 and P3. So this is the Gantt chart, P4, P2, P5, next P1 and P3. So you find out the Gantt chart first. Then you write that the process is given, arrival time is given, burst time is given in your program. Okay, you write that the completion time, P1 completion time is 19. Just you take from the Gantt chart, P2 is 14, P3 is 23, P4 8 and P5 is 60. Similarly, you find out that the turnaround time is completion time minus arrival time, waiting time, it's a turnaround time minus burst time. Okay, so average waiting time, here it's given that the average waiting time. So now here it's calculated the waiting time only, average waiting time. So you add that the 14 plus 7 plus 17 plus 0 plus 13 divided by number of process is 5. So the answer is 10.2. So here the option 5 is 10.2 second. Okay, so this is the first question. Next question, consider the following table, arrival time and burst time given, okay, in this 3 process P0, P1, P2, preemptive shortest job first scheduling algorithm. Already I told shortest job first, it's given the preemptive or non-preemptive. So preemptive means you find out the SRTF, non-preemptive means you find out the SJF. Okay, in this one already we know that the first one SJF is the simplest CPU scheduling algorithm which execute the process that comes shortest job first, so it is called non-preemptive. So non-preemptive means you find out that the SJF, preemptive means you find out the SRTF. Okay. So now in this one we take that the S or TF. So here that the process is given. So just I solved that the process P0, P1 to I am assigned that the P1, P2, P3. P1, P2, P3. Just you draw the Gantt chart. First Gantt chart, which is the Gantt chart, first one start from the first. So that is that you assign that the P0 is a P1. Okay, P1, P2, P3. 3 process is the. So first arrival time is 0. So 0 to 9 is the, but before that the 9th milliseconds, that is a burst time 4 milliseconds, that is that the next process will be arrived. So I will take only 1. Okay, 0 to 1. Next one, 1 we start that the next process, that is a P2. So what is the P2 burst time? 4. So 1 plus 4 is 5. So the remaining P1 is available is the, so the P1 So this is the difference between SJF and SRTF. SJF means shortest job first. Which is the shortest job first? 4. Okay, so first you take that 4 millisecond in P2 process, just you assign 0 to 4. But SRTF not like that. SRTF you take from the arrival time. The first arrival time 0 is minimum, burst time is 9. Okay, so 9 milliseconds is the 0 to 9, but in this before 9, the first 1 millisecond the P2 process will be arrived, so we take the P2. So the P2 will be assigned fully because the P2 burst time is minimum only. So 1 to 5 P2, so the remaining P1 is assigned. So already 1 milliseconds is there, so remaining 8 seconds, so 5 plus 8, 13, the last one P3 process, so 13 plus 9, 22. Okay, so here P1, P2, P3, so this is the exit time, that is the exit time means is nothing but it's a completion time. So P1 completion time, here that's a P1, both on the P1 is the final completion time, so 13, P2 is 5, P3 is 22. So now you calculate the turnaround time and waiting time. Already we know that the formula turnaround time is 13 minus arrival time 0, 5 minus arrival time 1, 22 minus 2 is that. So this is the turnaround time, waiting time. Finally you find out the average waiting time, because in this problem what is the average waiting time for the process is asking. Okay, so 4 plus 0 plus 11 divided by 3, so the answer is 5. So the first option A is the. Okay, so this is the SRTF method. So this is the difference between SJF and SRTF. Similarly, there is next problem. So given 3 processes given, P0, P1, P2, arrival time is given. Arrival time is not given means we take them the arrival time is 0, 1, but arrival time is given 0, 1, 2. So bus time also is given. Preemptive shortest job first. So what is the preemptive shortest job first? Is SRTF. Okay. Similarly, you find out P0, P1, P2, 0, 1, 2 is arrival time, bus time is given. So now you find out first you draw the Gantt chart, then you find out the waiting time, you calculate the average waiting time. So on this Gantt chart we start from the 0 millisecond P0. So P0, this is the SRTF. So first you take only 1 millisecond. After 1 millisecond P1 will be arrived. So the total burst time is 3. So 4. Next one we start from the P0 remaining, because in this both the burst time is same only. So we take the second one is the P0, last one is the P2. Okay, so you find out the average waiting time is 3.67 in this option. Second option is correct. Okay, so this is the SRTF. So the last problem in your question. So in this one, which of the following statement is false in the SJF? So first one statement is it causes a minimum average waiting time. S1. S2, it can cause starvation. Okay. So which is the false statements and not a true statement, it is a false. Only S1, only S2, both, and neither S1 or neither S2. So you know that in this SJF causes minimum average waiting time and it can cause starvation. So neither S1 and nor S2 is the correct. Okay. So in this section we see only the two scheduling. There is the first one is the FCFS, SJN and SJF and SRTF. So the next gate section we see that the next one round robin algorithm and priority algorithm. Okay. Thank you so much.